Hi ladies, Mrs. Blaufuss with 3.8. This is about solving linear systems. So if you remember from a couple lessons ago, we solved linear systems with two variables using substitution or elimination. And then we solved linear systems with three variables using elimination and then eventually substitution or elimination. But we're going to now solve linear systems with using matrices. And in order to do that, we need to find the inverse matrix of any particular, of one of the matrices in our equation, our coefficient matrix. So we're going to define a few terms first. So first, the identity matrix. We're going to identify the identity matrix just like the identity property of multiplication. 1 is the multiplicative identity, 0 is the additive identity. We also have our identity for a matrix. So in the identity matrix, there are 1s on the main diagonal and 0s everywhere else. So if A is any n by n matrix, meaning that it has the same number of rows as it does columns, and I is the identity, then A times I equals A, and it's also true that I times A equals A. So remember from 3.6, we don't have the commutative property for multiplication using matrices, but we do have that property, the commutative property, with identity matrices. The next one is our inverse matrices. So just like multiplication, we have an inverse. So 1 over 5 times 5 gives us the identity matrix. So this is true with, or gives us the identity of 1, the multiplicative identity. So this is true with matrices also. So with the inverse of matrices, we have 2n by n, again meaning we have the same number of rows as we do columns. 2n by n matrices, A and B, such that the product, and again this is in both orders, I times A equals A. Oops, sorry. The product in both orders, the identity matrix is A times B equals I and B times A equals I. So that would be A times B equals I, and B times A equals I. All right, this next term, matrix of variables. So if you remember, in a linear system, we would have, 3x plus 2y equals 5, and then negative 2x plus 4y equals 7. So our variables are x and y. So a matrix of variables is just going to be one column, and then the rows are however many variables you have. So we're going to use this in terms of a matrix equation. So for the matrix equation, AX, so matrix A times matrix X equals matrix B, X is the matrix of variables. And then for a matrix of coefficients, coefficients are the terms in front of the variables. So for a matrix equation, AX equals B, A is the matrix of coefficients. And then one that's not on here is the matrix of constants, and that's your B. So again, for a matrix equation, AX equals B, B is the matrix of constants. Okay, so just to kind of put this, we'll do a couple examples, but this is for linear systems. Okay, now the identity matrix, if you look back at that term, says 1's on the main diagonal and 0's everywhere else. If A is in the n by n matrix, and I is the identity matrix, then A times I equals A, and I times A equals A. So just to kind of give you an idea of what an identity matrix would look like, if you have a 3 by 3 matrix, you would have 1, 0, 0, 0, 1, 0, and 0, 0, 1. That is the identity matrix. So it has 1s on the main diagonal, and it has 0s everywhere else. So we're going to use our calculator to find the inverse of a matrix. You can do this by hand. So if you want to do this by hand, I'll give you kind of the formula that you're going to use for it. But again, remember, we're looking for the inverse matrix so that A, B equals I. So B is the inverse of A. So to find the inverse of A, if you want to know, kind of where this comes from. So the inverse of A, if A is matrix A, B, C, D, then you're going to find the inverse matrix by taking 1 over AD minus CD and multiplying that by D negative B negative C A. Okay, so that's the long way. That's by hand, and you can do that with a 2 by 2 matrix. We're definitely not going to do anything beyond 2 by 2 matrix by hand, but you could do this 2 by 2 matrix by hand. But we are going to use the calculator for this. So the first thing we have to do is put the 2 by 2 matrix in your calculator. So go to your matrix and edit. matrix, edit matrix A, so that is a 2 by 2 matrix, and you're working with matrix 3, -2, 4, oh, here we go, matrix, edit A, 2 by 2. So we've got 3, -2, 4, and -4. Now to find the inverse of this, we're going to use our inverse button. That's x to the -1. So first we have to get our matrix. So select matrix A, and then take the inverse of that. And you get decimals. Now don't use decimals when you're writing out a matrix unless you're dealing with dollars or something that makes sense to use decimals. But otherwise you always want your answer in fractions. So to do that, go to math, and then we want our number in fractions. So select number 1 or hit enter. And then it says answer in fractions. Yes, hit enter. So then it splits it up into fractions for you. So you have your matrix in decimals and then your exact answer matrix in fractions. So the next one, we're going to find the inverse. We're going to do it again. So here's our inverse of matrix A. So let's put that in our notes. So find the inverse of matrix A. Here we go. I'll just move it down here. Alright, so on your note sheet you can see that the A times -1 is already in decimal form, but put it in fraction form. You should be working with fractions unless it makes sense to use decimals. If there's already decimals in the problem, or something like working with money, it makes sense to use decimals, but otherwise use fractions. Alright, so the next one is you're finding the inverse of a 2 by 2 matrix, and it gives you the matrix 6, 4, 4, 3. So let's go to our calculator, and we're going to put it in our matrix. We're going to edit matrix A. It's going to be a 2 by 2 matrix, and it's 6, 4, 4, 3. Okay, so once you have that, you can quit and go back into the matrix and select matrix A, and then find the inverse of matrix A. Okay, again, it gives it to you in decimals, so let's go put it in fractions. And just to double check that this is the inverse, if you multiply the matrix by the inverse, you should get the identity matrix. So let's try that. Let's multiply this matrix by matrix A. So we're multiplying the inverse times the matrix, and there we get the identity matrix, which is what we should get. All right, so our next step now is to find the identity of a 3 by 3 matrix. So I'm just going to put this in the note sheet here. Okay, and on the next page, or if you look down, you've got a more complicated matrix. So this is where it gets really complicated to do it by hand. We're not going to do it by hand. So we're going to put matrix A into our calculator. So go to matrix. We're going to edit matrix A, and it's now a 3 by 3 matrix. Okay, so now we have to actually edit our matrix. 3, 2, -1, 7, 5, 0. And on your note sheet, this may have gotten cut off a little bit, but it should be 5, 3, -2. All right, then we can quit out of our matrix and go back to our home screen. And it says to find the inverse. So we're going to select matrix A. And then use our inverse button. And again, gives it to us in fraction form. So we'll go to math, enter, enter. And here's our fraction form. This is what we want. So again, if we do the inverse, if we multiply A times the inverse of A, we should get the identity matrix. If you don't get the identity matrix, then this is not the inverse. Okay, so for let's see if I can make this a little bit bigger. Okay, so here we go. This is our inverse of matrix A. Okay, now the next step is to actually use this inverse. Now that we know how to calculate the inverse, we're going to use it to solve a linear system. So in order to do that, we need to write matrix of variables, we need to write matrix of coefficients, and we need to write matrix of constants. So it's coefficient matrix is A, variable matrix is X, and constant matrix is B. So first we have to do that, then we need to find the inverse of A and multiply each side AX equals B by A to the -1 on the left side in order to find the solution. So let's start with the first step. All right, our first step is to write matrix A, matrix X, and matrix B. So our first matrix A is our coefficient matrix. So let's look at our coefficients. 2, 3, 1, and -2. Okay, so A equals coefficient matrix. So with this, you have to make sure that your coefficients are in the same order. So like your coefficient of X is first in both equations, and your coefficient of Y is first in both equations. Because that's how your matrix needs to be set up. So 2, 3, 1, and -2. So that's matrix A. Matrix B, matrix X equals the variable matrix. And this is just going to be a one-column matrix, and it's going to be however many variables you have. So we have an X variable and a Y variable. So that's our variable matrix. And then the last one, B, equals our constant matrix. So B, we have two constants, 15 and -17. So matrix A times matrix X equals matrix B. That's our matrix equation. Okay, now the second step, if you go back to your list, your second step is to find the inverse of matrix A. Okay, so let's do that. And this you can use your calculator for. So use your calculator to find the inverse of matrix A. So you go to your calculator in matrix. We're going to edit matrix A. It's going to be a 2 by 2 matrix. And it's 2, 3, 1, and -2. So now let's select that matrix A and find the inverse of it. Okay, crazy decimal. We don't want decimal. We want a fraction. So math, enter, enter, and here's our fraction. 2, 7, 2 sevenths, 3 sevenths, 1 seventh, and negative 2 sevenths. Okay, so this is the inverse of A. Now the next step. Okay, so we did that. We did step 2. Step 3, multiply each side of your matrix equation by a to the negative 1. It has to be on the left side because, again, we don't have a commutative property here. So it has to be on the left side. So if we do that, here we go. If we do that, multiply our matrix equation by the inverse on the left side. Here's our matrix equation again. A times x equals b. So if we do a to the negative 1 times a times x, a to the negative 1 times a times x equals a to the negative 1 times b here we have the associative property holds true for multiplication of matrices. So a to the negative 1 times a, that's the identity matrix. Okay, so it's like 1. It's nothing. Okay, so this we don't care about, it cancels out. It's just like 1 times x. So it would give us the identity times x equals a to the negative 1 times b. The identity of x is just x. So our x equals the inverse of a times b. So now we actually need to do the math. And you can use your calculator too for this if you want, but the inverse of a times b is going to be our x. That's what we're going to get for our x matrix. So we already have the inverse of a, but now we need to go to our calculator, we need to put in b. So we'll go to matrix, edit matrix B. It's a 2, it's a 2 by 1 matrix. And it's 15 and negative 17. That's matrix B. Okay, so we already have our inverse of A. We'll select A, take the inverse of that, and multiply that by matrix B. And here's our answer. So the inverse of A times B is negative 3 and 7. So x equals negative 3 times 7. Now, if you actually were to interpret that, what does that mean? That means our x matrix, which is x and y, that equals negative 3 and 7. So that means x equals negative 3 and y equals 7. Okay, so now I want you to try the second one on your own. So please pause the video while you work, and then you can unpause for the solution. Okay, so your first step is to get your coefficient matrix, variable matrix, and constant matrix. So you can see those listed here, and then to write your matrix equation. So A times X equals B. Your second step, after we do this first one here, your second step is to find the inverse of A. So your next step is to find the inverse of A. So the inverse of A is 5 11ths, 2 11ths, negative 2 11ths, negative 3 11ths. And then you are on your last step. So we did this. Our next step is to multiply each side of our matrix equation by the inverse. And again, when you multiply the left side, you get the identity matrix times X equals the inverse of A times B. Well, remember the identity matrix of X is just X. So that equals A to the negative 1 times B, or the inverse of A times B. So your next step is to actually compute the inverse of A times B, and you can use your calculator. And when you use your calculator to compute that, you should get X, matrix X equals 4, negative 2. Now, what does that actually mean? It means that X is 4 and Y equals negative 2. All right, and then the last problem is solving a multi-step problem. So in this one, we actually have to set up our equations. So solving linear systems, you still are gonna, if you have stored problems, are gonna have to set up the equation. This case is no different. We have to set up our matrices. So we're gonna set up our constant matrix, our coefficient matrix, and our variable matrix. But before we do that, we need to actually figure out what our equations are. So a company sells 3 types of movie gift baskets. A basic basket with 2 movie passes and 1 package of microwave popcorn costs $15.50. So we have package A, basic package. It has 2 movie passes, microwave popcorn, and it costs $15.50. A medium package has, well, let's highlight movie passes. Movie passes, packages of popcorn, and DVD, and that has a cost of $37. Super basket, well, that's package C, with movie passes, popcorn, and DVDs, and it has a cost, $72.50. So let's write 3 equations because we have 3 baskets. So our first equation is basket A. Okay, that's the purple. Oops, I should have done this in a different color. Okay, so the purple basket, the first one, basket A, it's a basic basket. It has movie passes, popcorn, DVDs, and a cost. Okay, so the purple one, it has 2 movie passes. It has 1 popcorn. And it has 0 DVDs. And that costs $15.50. Okay, our second one, our green one, the information I underlined in green is the medium basket. It has 2 movie passes. It has 2 packages of popcorn. And it has 1 DVD. And that costs $37. And then the third one, the one I underlined in blue, has 4 movie passes. It has 3 packages of popcorn, and it has 2 DVDs, and that costs 30 or 72.50. Now, I did not simplify this. I did not put this in its simplest form because I want to know my coefficients. So notice in the first equation how I have 1p and 0d. That's if you were writing it. If you were just writing out the equations, if the test asked you for an equation, you would have to simplify it. You would have to simplify it as 2m plus p equals 1550. But I put those coefficients there so that I can set up my matrix easily. So I want my coefficient matrix, that's matrix A. So matrix A is my coefficient matrix. 2, 2, 4, 1, 2, 3, and 0, 1, 2. My variable matrix is M, P, and D. And then lastly, my constant matrix is B. And that is 1550, 37, and 72. So now that I have my matrices set up, I'm going to do just like I did in the last problem, and I'm going to use matrices to solve this linear system. So first, I have to find the inverse of A. And so to do that, I'm going to use my calculator. So in matrix A, I'm going to edit. And this one is a 3 by 3 matrix. Okay, and once I have my info put into my matrix A, I'm going to find the inverse. So I'm going to select matrix A, and then find the inverse of that matrix. And you can do that math, enter. It's to get your correction. I made a mistake, but it's -1/2. Okay, these are 0.5. You can put those pretty easily into fraction form. So let's go back to our notes, and matrix, the inverse of matrix A is 1/2, -1. And actually for this one, we're using dollars, so it does make sense to do it in decimal form. So 0.5, which is like 50 cents, -1, 0.5, 0, 2, -1, and -1, -1, 1. That's our inverse matrix. Now our next step is to multiply both sides by the inverse matrix. Now we know that if we multiply the left side of the equation, matrix equation, by the inverse matrix, AX. If we multiply the left side by a to the -1, or the inverse of A, we are just going to get X. So we get X equals the inverse of A times B. So now let's just do the inverse of A times B. So go back to your calculator, put in matrix B. Edit matrix B. and it's a 3 by 1 this time. And it's 1550. And it's 37. And it's 7250. Okay, and then put it over there. And then we want to take the inverse of A times matrix B. And this is going to give us our cost. So 27, 150. Okay, so I had an error when I put in my matrix. That's why I had a negative 20 before. Negative 20, the reason that was wrong was because it didn't, something's not going to cost negative $20. In this case, that would have been referred to the DVDs costing negative $20, which I knew that wasn't right. So go back, if your answer doesn't make sense, go back and check your inputs to make sure that those are correct. So when I fixed my inputs of my inverse matrix here, and then multiply that by matrix B, I got 7, 1.5, and 20. So that means that X equals, matrix X is 7, 1.5, and 20. So what does that mean? It asks you find the cost of each item. So just leaving it like this is not finding the cost of each item. You need to actually say that movie passes are $7. And then you need to say that popcorn is $1.5 or $1.50. And then lastly, DVDs are $20. Okay, so I know this video is a little long, but thanks for watching. Please jot down any questions that you have, and we can go over those in class next time I see you. Thanks.